Hello everyone, and today's class we'll be seeing structures and unions in C. We'll also see the difference between structures and unions. How do we access the members of structures and how do we access the members of unions? And what's the advantage of structure and what's the advantage of union? So these illustrations we'll actually see in today's class. I'll share the screen where I'll be working to illustrate these topics. Okay. To begin with, we'll have a structure. So to define a structure, we need to use the keyword struct. So let me go for defining a structure student. So as you know that structure is actually a collection of heterogeneous elements of different types. For example, array is a collection of homogeneous elements. If I tell integer array, it can have only integer elements in it. If it's a floating point array, it can have only floating point elements in it. But structure is not like that. It's actually a collection of heterogeneous types. One structure can have different data type variables enclosed within itself. For example, we are seeing a structure student here. So let us have few attributes for student. For example, student has a name, so which is actually a character array. So I can write it as a name, and we'll be reserving 25 character, reserving 25 places for 25 characters, and then we'll have age, which is an integer which I've taken, and then I'll take float for CGPA, that is his average score. So let us have three fields in it. So if you can see here, all the three fields are of different types. Name is actually a character array, age is an integer, and float is a CGPA, which we have actually used it here. So we have defined a structure student. So this is collection of heterogeneous types. So now how do we access the members of a structure? How do we assign values to the members of a structure? So well, we can do that by creating an object or creating a variable of the structure. So how do we create the variable of a structure? So to create the variable of a structure, we need to follow the procedure where we have to declare the type, that is struct student, and the variable name s1. So if I go for static initialization, I can actually initialize it in single line. So within a pair of braces, I need to be writing the members in the sequence of their appearance in the structure. So first is name, so I'll be writing the name, and then age, so I'll be writing age, and then CGPA. So this is how we need to initialize a structure. So let me see whether these variables are actually stored in my structure variable. So we'll do that through a print statement. We'll go for printing the structure. So I'll be writing student details, and then I'll give a \n. Okay, so we'll be printing the student details. Okay, yes, and then how do we access the members of a structure for printing them? So this is a procedure which we actually follow. So printf. So first one is actually name. So I'll write name, and then it is a string. So let me write percentage. Yes, it's a character array, which we call it as a string. So the format specify used is percentage %s. And then in the next line, I'll go for printing the age. So I've given a \n, and since age is an integer, we go for percentage %d format specifier. Again, we'll go to the next line for printing the CGPA, which is actually a floating type value. So we have given percentage %f. Now to access the individual members of a structure, we need to use the object, that is the variable name s1, and we need to use membership operator, that is dot. Dot is called as member access operator, and the variable name, that is name. So if I want age, then s1 dot age. If I want CGPA, then s1 dot CGPA. So this is how I actually can access the members of a structure. To access the members of a structure, we need to use member access operator. So dot, write a comment line, so which would help you in further understanding the program later when you run. So dot is member access operator. So your dot operator is actually a member access operator. So this is what we have done. We have written a static initialization statement. So this is called static initialization of structure. Static Initialization of structure. So this is your static initialization of structure. And then we are printing the details of a structure which we have initialized. So let's see how actually the program works by running it. Okay, I have to choose the programming language here. So let me choose it. So we have created a small error. That is, we have written our CGPA in capital, and then in our main, we have written in small case. So I'll keep it everything in small case. So CGP. So this should remove our error. That was the error actually. We have kept it in capital case in the structure and small case in the main. So since C is a case sensitive, these errors are common syntax errors when you mismatch the cases. So if you can see here, a program has successfully executed. So we had a structure which was statically initialized. We had a structure which was statically initialized. If you can see here, so I'll keep the output as well as the program. So there was a structure which was statically initialized with the values, that is wiki 29 and then 9.7, and then I'm printing those values in a printf statements, and then using the variable name of the structure, I'm actually accessing the members of a structure using member access operator, that is dot operator. So this is a structure can be accessed. So since we have gone for static initialization, I can also go for dynamic initialization. So how do I go for dynamic initialization? Clear? So how do I go for dynamic initialization? So in order to go for dynamic initialization, so I'll go for struct, I'll create another object, student s2. I'll not initialize it here. So what I'll do is I'll write a statement for reading the values. So I'll write printf enter student details backslash n, and what details we are actually asking him to enter. So let me put it in a bracket so that it is understood, clear, right? Or I can also tell what details I'm accessing. So that is name, age, and CGPA, so that while entering, it's just a hint for him to enter three details. So let me go for writing a scanf. So first one is a string, we'll write percentages. Next one is percentage %d, that is integer, and then we have percentage %f for float. So how do we access? If it was a general variables in the main, we would have written name and then ampersand age, and then we would have written ampersand CGP. Okay. For name, if you see here, I have not written address access operator. We have not written address operator. I have not written ampersand. Why? Because for strings, the name itself acts as an address, starting address. So this was the case if it was declared in the main. But since now they are the members of a structure, if I have to access them, I need to use the object of the member. So if you can see here, I cannot write directly name. I should write s2.name. So here also I should write s2.age, and I should write s2.cgp. So this is how I can actually access the values for the members of a structure. So let me write a statement here, enter student2 details, so that we'll come to know it's an output of student2. Okay. And then we'll keep those statements below our student1 detail so that the output is clean. Okay, so enter student2 details. So here we'll just write student1 details. Okay, now we have read the student2 details. We'll go for printing the student2 detail. So we'll copy the same statements. We'll just change the variable name. So printing student2 details. So name age. So instead of s1, I should write the variable name as s2. So that's the only difference which I had made with respect to the first variable s1. So what happens here? We have written a small program for structure where we have one object which is statically initialized, and we have another object s2 which is dynamically initialized. That means I've read it from the keyword. So we call it as dynamic Initialization. So reading from standard input. So reading from standard input. So we take our standard input as keyboard. Okay, so we'll run this program. So I should get output like the first these details should be displayed, and then it should ask me to enter the details of student 2, and then student 2 details have to be printed. So we'll run this program. Okay, so if you can see here, it has successfully printed the student 1 details till here. And then it is asking me enter student 2 details, name, age, and CGPA. So let me enter name first. So let me enter name. Okay. And then let me enter age. And then let me enter the CGPA. Fine. Okay. So if you can see here, it is printing student 2 details. Clear? Okay. And here we'll include a new line so that our output comes in a proper line. So this is what is a simple program which actually tells you how do you access the members of a structure. How do you declare a structure? How do you put members into the structure? How do you access the structure members? How do you initialize it statically, and how do you initialize it dynamically? And it also tells how to display the details of a structure. So coming once again, structure is a collection of heterogeneous types. Structure is collection of heterogeneous types as a single unit. As a single unit. So this was about the structures. So this was about the structures. So what we'll do is now we'll go for a union. So we'll go for a union. Okay. So union is a keyword used, and then I'll go for the same. I'll go for another topic, that is employee. I'll use union for storing employee details. So I have a union called employee, pretty much same like structure. Only difference is we use a keyword union. Union is also collection of heterogeneous types. Union is also collection of heterogeneous types. So we'll see what is the difference between union and a structure. Fine. Okay. So union is also having a character name for employees. So I'll write name. So we'll reserve 25 characters. Okay. And then we'll have age for employees. And then we have floating point salaries we'll take. So I'll write sal. Okay. So there is a union for employee, and it is having 3 members: name, age, and salary. So what is the difference is? The difference is with respect to memory. So I'll write down here, structure reserves space for all members. Structure reserves space for all members, whereas union reserves space for one member at a time. So it has space reserved for largest member. Okay. So what I'm telling with respect to this is, in case of a structure, the total size taken by this particular structure, if I have to tell about a 16-bit machine, so if I have to tell about 16-bit machine, structure, size, so I'll write in bracket, I'm telling with respect to 16-bit machine. So 16-bit machine, if I'm telling about the size of a structure, so it is the size of character name which has been declared, and plus the size of age plus the size of CGPA. So if you can see here, the size of the character name as it's an array is 25, and size of individual character is 1 byte. So 25 into 1, so that is 25 plus 2 bytes for integers plus 4 bytes for float. So the total size taken by that particular structure is 31 bytes. 31 bytes. So I'll write down in bracket for which it is taking. So name, and then 2 bytes for age, and then 4 bytes for CGP. This is the total size, structure size. So if I have to tell about union, what's the size of an union? So our union, so I'll write here, union size, tell about 16-bit machine. So 16-bit machine. Okay. So size of the union is maximum member size. So that is the maximum member size. That is 25 bytes. So if you can see here, the size of this employee is 25 bytes and the size of the structure is 31 bytes. Why 25 bytes? What union does is it reserves only that much memory which is required for its largest member. So if you can see here, age takes 2 bytes, float takes 4 bytes, and this character array name takes 25 bytes. So it reserves 25 bytes for itself. And one member at a time can be accessed and initialized, not like a structure. So in union, one member can be accessed and utilized at a time. So that's the difference. In union, only one member can be accessed and utilized at a time, since they share common space. So that's the difference in union. Only one member can be accessed at a time. Together, we cannot access all the members of a union. But in structure, that's not the case. All the members can be accessed simultaneously. So in structure, all members can be accessed simultaneously. So this is what is difference between structure and union. So now we'll try to illustrate it. So what I'll do is the first part which we have used for initializing a structure, I'll just command that part. So we'll just see structure and union difference in this particular topic which I'm currently explaining now. So what I'll do is I'll declare a structure variable that is using struct student. Okay, so let me declare s3. Okay, so how do you initialize the values of the variable? I can do it like this. S3 dot name is equal to, I can do it individually like this also. So let me write wiki. So this is the name which I've initialized. So if you can see here, and then I'll go for initializing age. So S3 dot age is equal to 29. And then I'll go for initializing the CGPA. So CGPA is equal to 9. Clear? Okay. So I have initialized. So 9 point will give, because it's a floating point number. So 9.7. So now I'll go for printing this particular member. Clear, right? So I'll tell student details and I'll go for printing the details of that particular variable. So I'll write student details. Fine. Okay. Since student is a structure, so I'll just write in bracket, it's a structure. I'll write structure student details. Okay. So since the variable name is S3, so let me go for S3 dot name, S3 dot age, and S3 dot CGPA. So this is also a kind of static initialization where individually I have initialized. In the previous example, we have seen how could we do that using a pair of braces. But now I've done individually. Clear, right? It's for explanation of this current topic, difference between union and structure. So let me run this piece of code now. Okay, so there is a small mistake which we have done. Okay, since it is an array, I've directly initialized it using the variable name. So let me go for initializing it in this fashion. Fine. Okay. So let me go for initializing it in this fashion once again. Since it's an array, I need to go for initializing it. So we'll initialize it statically in this, or else I need to go for dynamically initializing. So I'll go for dynamically initializing or statically initialize. I'll initialize it here. So what I'll do is I'll write name, the same details which we actually used it. Okay. So we have the same details being written here. So we'll use the same details of initializing it statically. Okay. So this is how I'll do it, because it's an array. I cannot do it in a direct initialization like that. So this is what is suiting us. So if I run this program, it actually prints the details of a student. So if you can see, the three details of the students have to be printed. So all the three details of the particular student are being printed. Fine. Okay. So now if I go for union now, so this was on the structure. So let me go for now a union. So what I'll do is, same way I'll declare a union. So union, the name of union is employee, and let me declare one variable for that union. So it is u1. So same way I can go for initializing the union members also. Okay. Yes. So see here, I'm initializing a union member. So name of the employee, I'll keep it as cat, and then age, I'll keep it as 9, and then salary, I'll keep it as 9,000. Fine. Okay. So I have a union member here. So now we'll go for displaying this particular union member. Same way, how do we display structure? In the same fashion, we can actually go for displaying the union also. Okay. So I'll just change the print statement. So I'll write it as union. So it's not student details, it's employee details. So I'll write employee details. And then since the name of that particular union is U1 variable name, so we'll go for changing that U1. And then we don't have CGPA as an attribute, we have salary. So U1 dot salary. So if you can see, both are doing the same job. We have static initialization for union also, static initialization for structure also. And I'm printing the details of a structure, and I'm printing the details of the union. So you can see here. Okay, so we'll write new line so that it comes to the next line. So that our output is neat and clean. Okay, so we'll run this and we'll see what happens. Okay, so if you can see here, in the union, if you see, name has come properly, but age, it took garbage value, and CGPA also, it took garbage value. That's the difference, because one member at a time can actually access the memory space. So what happened with the static initialization is, it only reserved the place for name, and that particular 25 bytes were reserved for name. So whatever I gave for age and CGPA were not taken and stored in the memory, because it reserved only one room at a time. So we lost these two values, and that's why you can see some garbage values in age and CGPA. Okay, so illustrate it properly, what I'll do here is, after this particular statement, I'll go for changing the age. So I'll go u1 dot age is equal to 27. I'll write u1 dot age is equal to 27, and then I'll run the program. Okay, so if you can see here, now name, it took garbage value, and age, it gave the proper value 27, because the latest variable which was actually utilized was age. So what did they do is, when I gave, I have to use age, it erased the contents of name, that was Prakyat. So Prakyat was actually the name which was stored in the union. It erased it, and it utilized that room for storing age. So now if I go for writing CGPA, u1 dot CGPA is equal to, sorry, union is for salary. So u1 dot salary is equal to 7,000. So if I do like this, Now what happens is it will erase the age also, and it will use that room for storing only salary. So name and age will get garbage value. Salary will be correctly printed. So we'll run this. Okay, so see here, name and age, I got garbage value, but salary was correctly printed. So this is what is a difference between union and structure. In structure, all the members will have a separate rooms given for them. But in case of a union, only one room has to be shared by all. And what is the size of the room? The size of the room is the size of the largest member. So since in our structure, the largest member was a character array name, so size of that particular union was 25 bytes. But the size of the structure was 31 bytes. Now we'll go for running a small piece of code which actually tells the size of a structure and then size of the union. But you should be very careful. This computer is not a 16-bit machine. It's a 32-bit machine. The smallest room space is of 4 bytes. So for character also it takes 4 bytes. For integer also it takes 4 bytes. For float also it takes 4 bytes. Why? Because this machine is a 32-bit machine. So be careful in calculating. So let me show how will we actually calculate the size of the members, data members. Okay. So we have an inbuilt operator for doing that. So before that, we'll find out what is the size of characters. So printf, I'll write size of character. What is the size of the character? So percentage D backslash N, I'll write. And then I'll write, we have an inbuilt operator for doing that. That is size of, where I can actually pass a character or I can give the data type name also. Okay. So this will tell what is the size of character in my system. Clear? Okay. So in the same way, we'll find out what's the size of integer and what's the size of floating point number. So size of integer. So we need to tell what's the size of integer in this particular. This is how I actually find out what's the size of the data types in this my particular system. Because this is not a 16-bit machine, it's a 32-bit machine. So the smallest room size is of 32 bits. That's equal to 4 byte. Okay. So we'll do this. So since I don't want this particular part, I'll comment this particular part so that you can uncomment it whenever you want. So I'll just write a comment saying that illustration of difference between structure and union member access. Okay. And then here I'll write a comment illustration of member access in structures. Member initialization and accessing structures. Okay, so this particular code, what we are actually writing, we are writing it to find the size of the variables. Clear, right? So size of the data types first we'll find out in this machine. What's the size of character, what's the size of integer, and what's the size of floating point number. So I'll just run this piece of code. Okay, so if you can see here, character it takes 1 byte, integer it takes 4 bytes, size of float is also 4 bytes. So why integer and float are taking 4 bytes? Why? Because it's a 16-bit machine. So size of integer is also taken as 4 bytes and size of character is taken as 1 byte. But when we store a single character variable, for example, assume I have an integer. For example, let me write here int a equal to 7, and then I'll write character b is equal to c, one variable I have stored, and then we'll write float c is equal to 7.2. Okay, so now we have 3 variables. One is of integer, one is of character, another is of float. So now we'll find the size of them. Fine. Okay. So how can I do that is, I'll use the same printf statement. Size of character variable BL, right? So instead of writing char here, so let me go for B. Then I'll write size of integer variable A. So size of A. And then we'll write size of float variable C. So let me write here variable name. So I'm not writing data type here. I'm writing the variables B, A, and C. B is of character type, A is of integer type, and C is of floating point type. So now if I run this particular code, okay. So if you can see here, either I can use the data type or I can use the variable. It's going to show me the same size. Okay, now this was individual. Now we'll see what is the size of our structure and union. So what I'll do is I'll write the same statement. So I'll write size of structure student. So I'll use a variable of that particular structure. So previously we have declared S3. So I'll write S3. Fine. And here we'll go for size of union employee. And mind you, this is not 16-bit machine. It's a 32-bit machine. So size will vary on what theoretically we have said. So be careful on that. Don't get confused. Theoretically, we say this character takes 1 byte, integer takes 2 byte, and floating point takes 4 bytes. But you have seen here, it's not the case in this machine. Character takes 1 byte, integer takes 4 bytes, and float also takes 4 bytes. It depends on machine architecture. And this is not a 16-bit machine. It's a 32-bit machine. So the architecture is actually changed in terms of storing integer and floating point. Clear? Okay. So now we are finding the size of a structure student and size of a union employee. Fine. Okay. And then size of S3 and size of S1. S3 is of student structure variable, and then U1 is of union employee. So I'll run this. Okay. So if you can see here, structure takes 36. Structure takes 36 bytes, and then union employee takes 28 bytes. So union takes 28 bytes. So why is it 28 bytes? Clear, right? It is a bit confusing because my name is 25. My name is 25. You can see here my name is 25. And according to our definition, it should have taken 25 because one character takes 1 byte. Clear, right? Then why did it take 28? Okay, this is because we are using a 32-bit machine. So in 32-bit machine, each room is of 4 bytes. So I totally want 25 bytes. So minimum how many rooms I want? I want minimum how many rooms for storing 25 bytes? So the answer is I want 7 rooms. How 7 rooms? Because 6 rooms, if I take 6 fours are 24. One character is left out. So totally I want 7 rooms. So the size of 7 rooms is 28 bytes. Why? Because each room is of 4 bytes in 32-bit machine. I know there are 3 rooms wasted. Because I need 25 rooms, it gave me 28 rooms. Because in this particular computer, the size of a single room is 4 bytes. So that's why the size is 28 bytes. So be careful in understanding this particular output. Because theoretically, we don't tell 28 bytes. We just tell the union takes 25 bytes and the structure takes 31 bytes. But here, my structure took 36 bytes. Why 36 bytes? It took 28 bytes for name and 4 bytes for age and 4 bytes for CGPA. So totally it was 28 plus 432 plus 436. So you can see here 36. And why 28? Actually wanted 25. But my single room is of 4 bytes. So since I want 25, the minimum rooms it could give me was 7. So 7 fours are 28, where I utilized only 25 bytes. 3 bytes are wastage. That particular wastage is called internal fragmentation. That's a topic which comes in higher IT syllabus, internal fragmentation and external fragmentation, where I want 25, but since my minimum room space is 4, I was given 28. So that 3 rooms are wasted. It's of no use. That particular concept is called internal fragmentation. So this is what is with respect to the size of the structure. Fine. So I'll write a comment lines to tell you that this particular piece of code is for illustrating the size of data types. So whenever you are running individually, uncomment the blocks and then run for seeing this output. So I'll write size illustration of data types. So we'll understand the output. So I'll write the command output 36 bytes. So why is it 36 bytes? So 28 for name and then 4 for age. So 28 plus 4 and then 4 for CGP. So that's why it came. And in a bracket, we can write 32-bit architecture. So this is a 32-bit machine. So that's why the output gave like this. Clear? Okay. So what is the output of this particular? So output will copy paste the sentences. Control V. So it was only, sorry. So the output was only 28 bytes for this particular line. So the output was only 28 bytes for the name. So why is it? Because name is a largest member. Largest member. So that's why it took only 28 bytes. So why 28 bytes? So I'll give illustration here also. Each word we call is 4 bytes to accommodate 25 characters, minimum 7 words, minimum 7 words. So 28 bytes. What do you mean by word is nothing but what I was calling room. Clear? The smallest room in your computer is called as a word. The smallest chunk of memory which can be read is called as a word. So each word is 4 bytes in this 32-bit machine. Each word is a 4 bytes in this 32-bit machine. Clear, right? So in 32-bit machine, each word is 4 bytes. So to accommodate 25 characters, minimum 7 words are required. So since it is minimum 7 words are required, so the 7 words are actually taking 28 bytes. So that's what is an explanation of these two statements. Fine. So this should clearly explain you what's the difference between structures and unions. In case of any queries, you can get back to me. Fine. Okay, you can text me or you can mail me also for contact trainer. So if you have any queries, you can actually mail me to this particular email ID. I'll reply at my earliest convenience. Fine. I hope the concept of structure and unions are clear to you. In order to brief the concepts of structures and unions, let me illustrate or let me go through, brush up the concepts once again. Both are collection of heterogeneous types. Both structure and union are collection of heterogeneous types. The difference is in a structure, the members can be accessed simultaneously. Why? Because each member is being given a separate room space, a separate memory location based on its size. But in case of an employee, the room is only given to the largest member size. and all the members have to share the same room. So since they share the same room, only one member at a time can be accessed in a union. So if I'm using name, only name can be accessed. If I'm using age, only age can be accessed. So when I'm using salary, it erases the content of that room and only uses it for salary. So other two will get garbage value. So that's what we have seen in the output. So the total memory utilized by a union is actually equal to the size of the maximum member. So that is, in this particular three members, the maximum size is of name. So size is of name. But theoretically, it was 25 bytes. Why I am getting 28 bytes in my answer? That is because this computer is 32-bit machine. That means it takes 4 bytes for single room or word. So to accommodate 25 characters, minimum I want 7 rooms. So 7 rooms, each of 4 bytes. So total size is 28 bytes. And if you see the structure, the size is the size of all the three members added. Theoretically, it is 31 bytes when we are talking about 16-bit machine. But since it is a 32-bit machine in which I'm running this particular program, name takes 25 bytes as I've explained, 7 rooms of 4 bytes each, so 28 bytes. Age is of 4 bytes in this machine, so 28 plus 4 is 32. It is of 4 bytes, so 32 plus 4, it is 36. So that's why the answer is 36 for a structure. So this is how the structure and union differ in your size also. Okay. Hope this session was quite enough to illustrate the difference between structures and unions, and how do you access the members of a structures and how do you access the members of a union. In case of any queries, you can write to my email. So I'll get back to you at my earliest convenience. Thank you, and then happy learning online.